Hello everyone, welcome to this video on Demand Driven Replenishment by My Supply Chain Group Consulting. My name is Sanjay, I'm a Supply Chain Planning SME. Along with me today I have Himanshu.
Hi everyone, I'm Himanshu. I'm a Supply Chain Planning SME and I'm going to talk about Demand Driven Replenishment.
Himanshu, we all know about the traditional ways of planning. Let's start with understanding a little bit more about what is DDR and how is it really different from traditional planning.
Now, Demand Driven Replenishment is a methodology based on Goldratt's theory of constraint to manage the business. It helps to alleviate the supply chain constraints, for example, production capacity, long lead times, labor constraints, etc. It uses the inventory buffers at strategic nodes in the supply chain. DDR decouples the overall replenishment lead time using buffers and thereby improves service levels. The main objective with DDR is to enable material flow through a supply chain. DDR achieves this by dampening the effect of variation across the supply chain, by decoupling lead times and identifying where to buffer quantities of inventory, as well as the amount of inventory required at those points. DDR tells us how much to buffer so as to ensure that there is shortest possible lead time to fulfill the demand and optimum amount of inventory is stocked. SAP has provided a tool to support and manage all processes and steps as ascribed by Demand Driven Institute effectively.
I'm sure DDR must have certain benefits. Let's talk a little bit around those benefits that it gives us over the traditional planning.
Sure, Sanjay. The first benefit that we get out of the Demand Driven Replenishment is that it is a process-driven methodology, rather than just dependent on the tool. The second is that it handles the bullwhip effect better because inventory buffers are available at strategic points in supply chain. Inventory buffers also help to manage demand and supply variability. The third benefit is that DDR reduces total replenishment lead time by decoupling the supply chain. The fourth benefit is that there is no need for forecasting as the process is driven by actual customer orders. Fifth benefit is that there is no need for any additional complex solvers. The SAP DDR is an end-to-end supply planning solution which provides the better analytics, thereby measuring the relevant KPIs as needed by the business.
That's actually interesting, Himanshu, because if you look at the forecast not needed, right? I think that would really be something that most of our clients would like to know more about since it's based on actual demands. So talking of that, what are the different drawbacks of this process over traditional planning?
Yes, Sanjay. So let's get into the details of the drawbacks that, I think the first drawback that we can see is that there is no clear guidance on economic inventory values. Then the second drawback that we see is that since there is no forecast, so it's very difficult from S&OP, long-term S&OP planning processes. The third drawback that we see is there is a need for a separate planning solution or scheduling solution for scheduling the orders on the shop floor, because DDR doesn't do the scheduling. The fourth drawback is that there is no economic optimization possible with the DDR.
So with this, right, Himanshu, the advantages and disadvantages, I'm trying to think what industries would it really be applicable to? What industries does this apply to?
Yes, Sanjay, definitely. Let's talk about the industries. So the first industry is the consumer products industry. The consumer products industry, I think DDR is definitely relevant because of the high inventory turnover that we see in this industry per se. Then the second industry that we can think of is distribution and retail. Again, there's shelf space, is managed in this industry, and a lot of turnover is there. So you need to have stocks at different levels in the supply chain to manage it.
With that background, let's deep dive and understand about the different steps involved in this process.
Yes, Sanjay. So the Demand Driven Institute has ascribed specific steps for demand driven replenishment process, and SAP actually supports all these 5 steps, as you can see on the slide. The first step is buffer positioning. The second is buffer sizing. The third is dynamic adjustments to these buffers. And fourth is demand driven planning. That is planning your supply chain based on the buffers that are determined by the DDR tool. And the fifth is to visualize the plan and act on it, like you manage the plan based on reports and KPIs that you will generate. And the first 3 steps are entirely driven out of SAP IBP. The step 4th, which is planning, it is managed in SAP ERP or SAP S/4HANA system. The 5th step can be managed in S/4HANA to some extent, but IBP is the tool of choice to manage this 5th step. Because in IBP, as I said earlier, we have very strong analytics and visualization capabilities.
So Himanshu, coming out of my past experiences, I know that this process can be entirely managed within the S/4HANA arena that SAP comes up with. Why do you think people should consider SAP IBP to manage this DDR process?
IBP provides certain advantages over S/4HANA when it comes to determining the demand and supply variability or categorization of demand and supply variability. It's much easier to do these things in IBP as compared to S/4HANA. There are more advanced tools available to perform these activities. Then IBP uses user-friendly web and Excel UI, and it provides seamless transition for planners who are already using Excel for their day-to-day planning tasks. It helps curtail the effort and cost associated with training and change management when it comes to implementing the demand-driven replenishment process. The tool can help there.
I see. So with that, Himanshu, can we deep dive into each of those steps and see a little bit more about what they have to say?
So buffer positioning is nothing else but recommending the strategic points in your supply chain, right, which are also called as decoupling points, where we place the buffers to reduce the variability. So DDR enables creation of scenarios for decoupling point decisions and places the decoupling points and their associated buffers in the supply chain based on several factors. So let me just discuss a couple of these factors that DDR has to consider. The first factor is critical operation protection. As in, we can define, as a planner, I can define which operation in my supply chain is critical, and hence I would like to keep some buffer for it. The second critical point is customer tolerance time. So depending on the customer and its required service levels or tolerance in terms of the lead time variability, we can determine which point in the supply chain needs to be a decoupling point. Then inventory leverage and flexibility. Then sales order visibility horizon, for how long we have the sales orders available. Based on that also we determine which points should be decoupling points. Potential lead time to market. So as I said earlier, DDR decouples the lead time, thereby reducing it. So that's an important point to consider. Then variable rate of demand and supply. So it considers both demand variability as well as supply variability to come up with the decision of at what point in the supply chain should we keep buffers. The next logical process step in this whole process is to calculate the average daily usage, as in how much your average demand is as compared to what was your previous sales and what is your future forecast. So DDR calculates average daily usage and variability of average daily usage using the past and future sales, or also it can do it using the blend of the two time horizons, past and future. It is an average over the past and future horizons as defined in the system. So you can define how much past horizon and how much future horizon system has to take for each data point, being product and location in this case.
So Himanshu, I think overall the way I understand right now is the ADU seems to be a really critical piece of this entire calculation and the entire 5-step process that you showed us. Where exactly does this fit into that circular picture that you showed us earlier?
So ADU is pretty critical to the whole process. It is so important that without it, it would not even calculate the buffer levels. Essentially, you need a demand to, to consume the inventory. So the next step in the process, Sanjay, is to calculate the buffer zones, because it's not enough to just identify where should I keep the inventory, but how much inventory do I need to keep. So DDR calculates the buffer zones. So buffers are levels of inventory that are sized and maintained so that the inventory remains at the optimum stocking levels, and we are not running out of inventory, or we are not keeping too much inventory so as to increase the overall supply chain cost. DDR uses a dynamic 3-zone color-coded buffer for planning and execution. The levels are calculated using individual item properties and the group settings, which is the buffer profile that we use for managing the buffers at the location level. Now, when it comes to individual item properties, so item properties are nothing else but the lead time that is required to procure that item. What is my minimum order quantity? Which location am I procuring this item to? Whether it is a DC, whether it is a plant. What is my average daily usage of that item at that location? The group level is item type. So it is like generic. So we categorize the items, what type of item it is, whether it is a long lead time item, whether it is a short lead time item or medium lead time item. That goes into the lead time category. Then not only the lead time category, but also the variability category. How much variability is there whenever we order this item? How many times does it, is received on time versus how much it is late or how much it is early? So that constitutes the variability part of it. So we categorize the variability in terms of highly variable, medium variability, and low variability. So based on these all these parameters, system comes up with the buffer quantities. And again, the green, the color signifies that you are good to go if you are in the green zone. Yellow is that we are still okay, but if we are in this zone, then we may be going into problems pretty soon. And red zone is nothing else but the safety stock. So the system calculates the safety stock, and it is termed as red zone because you will not be able to supply your demands if you are in the red zone. So it is time to reorder and replenish your stock levels.
I think that gives us a fair bit of theoretical background before we can jump into the system. So Himanshu, if you could drive us through a couple of web UI and Excel planning views. So
I'll take you to the web UI. So the first step in the process, as we discussed, was to determine the decoupling points. In SAP IBP web UI, we have an app for DDMRP buffer analysis. So in this app, basically we can create a scenario and we can compare the decoupling points for this scenario with respect to the base version. And then we can take a decision in this screen whether we want to keep a particular product location combination as a decoupling point or not. So here you see these toggle buttons. So if I say start scenario, it will calculate the decoupling points based on all these parameters that we just discussed. And then we still have an option to override what system has proposed. And we can just, using this toggle button, we can choose that yes, green is a decoupling point. And the benefit of the screen is that you get an overview on one screen about, and as well as the comparison between baseline and the scenario that we are creating. Also the difference, what would be my decoupling lead time if I keep this location product as a decoupling point or not? What would be my average on hand and in value terms as well. And the summary is also available at the overall level. Okay, so now this is the web UI. So the similar information is also available in SAP IBP add-in for Excel, and here we can see the data which resides in SAP IBP system directly. So the first view that we're gonna look at here is the view where we see the ADU calculation, ADU being average daily usage, right? So in this view, you can see what is my past history, what is my future demand, and what is my blended demand, basically taking the past history as well as the future demand into one key figure. And then system calculates the total average daily usage. In this view, planner has the ability to influence this ADU that system has come up with using this factor. So it is just nothing else but a multiplier. So planners can choose to update ADU. Next step in the process, determining the buffers. So system calculates the decoupling point, as you can see in the first row here. It signifies that it is a decoupling point. So this finished good at location 1310 is a decoupling point, and these are the other parameters that system considered to determine that it is a decoupling point, and then to determine the buffers. So here you can see the buffers that system has calculated, right? Green zone, yellow zone, and red zone, and then all these three rows are just beginning with red and then adding yellow on top of it and then green on top of it. So total, so maximum inventory that you should hold at for this day is 19,241, and if you are equal to or below 14,660 but above 5498, then you are in the yellow zone. If you are at 5498 or below, you are in the red zone. So that's what there's the information contained in this view. Then we have this third view where planners can come, and so let's say I want to make an adjustment and change the yellow zone from 9162 to 9100. So I can do that, and I can simulate just to see what changes it does. So after refresh, as you can see here, the data points, if you compare this data point within this week, 19241, but here it has changed from 19241 to 19179. So system does the whole recalculation on the fly, right, as soon as you make the change. Now I'll take you to the other planning view that we have, where we can see the recommendation from the system. Okay. So in this data view, basically it has a lot of information that we saw in the previous data view, but it also gives you the on-hand inventory, how much on-hand inventory do we have, how much is our total open supply, right, considering the on-hand inventory as well as confirmed supply orders. So now let's go to the fourth view that we have, where we can see the net flow position. So here we can see this almost the similar information that was available in the previous view, but in addition we can also see what is the confirmed supply that we will get from the execution system, what is the on-hand inventory available for the product location, then what is my overall supply, open supply including the on-hand inventory, then what is my confirmed demand or qualified demand as DDR calls it, and then net flow position. Net flow position is nothing else but the open supply minus qualified demand. How much is still available to fulfill the orders. Okay, so here we can see on-hand inventory, which is available to supply any demands that we may have. We do not have any confirmed supply. So for that time being, I'm gonna simulate that we are getting some confirmed supply from connected S4HANA system in IBP itself. So ideally, S4HANA would create a confirmed supply after your decoupled lead time, which is 14 days in this case, right? So I'll put a supply here of, let's say, I'll put a supply of 10,000. And then we'll simulate it just to see what is our net flow position. Right, so now we will go to the fourth planning view, where we can see similar information, but additionally, we can also see the supply coming in from the connected S/4HANA system, which is this key figure, confirmed supply quantity. We can also see the on-hand inventory, what is our total supply, what is our qualified demand being the confirmed sales orders, and what is my net flow position, which is open supply plus on-hand inventory minus qualified demand. So in this case, we do not have any open purchase orders or open STOs, so that's why open supply is blank. So it is just taking out the demand from the stock, which is available at the location for it. And then it also gives us what is the net flow status, which is nothing else but the comparison of net flow position and the top of the green, which is 19,000 to 41 in this case. So it tells us that we have 44% available net flow position. Now, if I want to simulate that I am receiving some confirmed supply from S/4HANA, so what I'll do is I'll put a confirmed supply here in this view and then simulate. Now, S/4HANA will typically create a confirmed supply after the decoupling lead time, which is 14 days in this case. So I'll put it here as, let's say, 10,000. Now let's simulate. There you go. So here you can see that open supply is 10,000, which is coming from this number, right? And your net flow position becomes 18,582, which is very close to what our top of green value is. So that's why the net flow status becomes 96%, because we are very close to our top of the green. So a similar set of information is also available. Let me just save this data, and then we'll move on to the fifth view before we move on to dashboards. All right, the data is saved. Now let's go to the fifth view. There you go. So whatever changes we made in the previous view, you can see them here as well, right? And also what we can see is the projected on-hand inventory in this view, as well as what is the on-hand buffer status, right? So this on-hand buffer status is with reference to the green zone execution. That sort of concludes the Excel part of it. Now I'll take you back to the web UI, and there we will see the dashboards that we have put together. And again, I would like to emphasize that dashboards are very, very flexible in IBP. We can create all sort of dashboards and KPIs measurements in IBP. So this is a dashboard where we can see the supply chain. Then we can also see the top 5 buffers in this dashboard. So it is just selecting all the top 5 products which are the highest buffer quantities, right, for any location. Here we can see the DDR calculated buffers for this product at this location. Here we can also see the alerts. So we can create alerts in IBP for based on the data that we saw in Excel. The same data can be used to generate certain alerts. So this is an example of critical low within the decoupled lead time, right? So if you go inside that, it will take you to further more details.
I think indeed that was really great insights into DDMRP for our audiences here today, Himanshu. Thank you very much for that. Just a closing thought here. I think we ran through how DDR is different from traditional planning, what are its advantages and disadvantages, and the process overall. So for the benefit of our audiences, we have our contact information up on your screen here. If you guys are planning to do anything around DDR and need some help, we are always there and just a phone call away. A last closing comment here. I think for most of the clients who are trying to explore to use DDR using SAP IBP in general, one point really to note here is it's a big process change overall. The implementation of the tool per se is really simple, but I think it's the principles and the overall change management that is kind of critical. So again, once again, thank you, Himanshu, for your time today. And
thanks.